Okay, my name is Eric Games. I'm a professor here at JSU. I have an office in the second floor, and I will teach you this course this semester, computer security. So my name is here. You have the syllabus, it is in Canvas. This is my office. This is my email. So when you want to talk with me, you can send me an email. We will be here in Air Hall 361 from 2:30 to 4. And it will be on Tuesday and Thursday. So normally I will be in time, but if you see that I'm not here at 2:30, come to my office. Okay, I might be busy thinking other things and I forgot that I have class, so just come to my office and let me know that you are waiting for me. Thank you for that. So here we have the textbook that we'll be using. Really, you don't need to buy it. So if you don't want to buy it, don't buy it at all. I will never open the book. Here, all the material that we need will be in Canvas. There is so much information in the internet and free information that we don't really need to buy a book. Okay, let me go through some policy. So I would like the course to be interactive, which means that sometime we will have questions. I want you to answer. Okay, I don't want you to be shy to answer. I do want you to answer. Of course, if you make a mistake, we will just say, okay, this is not correct. And maybe another person will try. And if we find the solution, that's fine. If you don't find a solution, well, I will give the solution at the end, no? But I do want you to participate, so don't be shy in that. When you write me an email, I'm teaching 3 different courses this semester. Please be sure the subject start with CS470. Okay, as you've seen, I've sent you already several emails. They always start like that. Even if you don't have confusion, if it's come from Eric Games, it might be, unless you are taking computer networking also, so it might be from this course. So if you are taking computer networking with me this semester, you might be confused. So I will always start with the subject that says CS470 on the topic that I want to discuss with you. Okay, so do the same thing, put the ID of the course at the beginning in the subject, so I can, okay, this is a student that is in this course, and I know at least it gives me a smaller number of students to think about. Okay, you know that we have a pandemic. The university is requiring masks, so be sure that you have your mask when you come here. I know I don't like it neither, and sometimes it's make me having cough, so I don't like it at all, no? But, well, this is the way that we can protect us, so be sure you bring your mask and you use your mask during all the class, no? So the way that we will evaluate the courses here, this will be based on homeworks. So we will not have exam in this course. You will do the homeworks. We have several homeworks. We will make group of 2 students, and each group will work in the solution. And we will have to upload a report in Canvas, no, by the due date. So I give all the, if you look, all the homework are already there. So you can look at them if you want. We don't have the background to do them in this moment, but soon we will have it, no? This is the content of the course. It is very ambitious. We will never see all of this. We will see part of it, no? So it depends how fast you learn, but my experience is that we never can cover all this topic. So another thing that I want you to know, I will be recording the class. So I just started already, the class is recording, so every class will be recording. That doesn't mean that you don't have to come. If I see that you don't come, I will really stop recording. Because I already have email students, oh, today I cannot do it. It's okay if you cannot do it one day. I don't like to record to tell you the truth, because I would like to be in front of the right board. But the problem is that if I record, I have to be close to the microphone so you can listen to me. And the fact that I'm forced to record make that I cannot use the right board. And it's so much fun to use the right board and do an exercise on the right board. So I have to do it in the computer. I don't like it because it's more limited. It's more difficult to use the computer to do that. So be sure you come, no? As I told you, if I see that people don't attend the class anymore, that's it. I don't record anymore. You cannot make it, you cannot make it. Okay, this is a course that you should be here. So you cannot make it, you cannot make it. There will be no recording. So it's you that decide if I keep recording or not. Okay, I'm supposed to pass attendance today. So let me do it. It is. Oh. Yeah, I know what it is. Must be this one. Yeah. Well, I don't know where I did put it, so my pass attendance next class. Let's be that. Okay, I will have to go to my office to pick it up, so I prefer not to do it today. So sorry for that. Yeah, we don't have it. Okay, I'm going to make some review today about something that we call the modular arithmetic, no? We will use the modular arithmetic when we will see public key cryptography. You will have this PDF file. I forgot to put it, but you will have it. So the first, we are going to make a review of some of the property of the modular arithmetic. So, for example, the first property that we are going to see is the symmetric property. So if A is congruent to B modulus M, then B will be also congruent to A modulus M, which means that you can invert the left part, you put it on the right part, on the right part you put it on the left part, and it will not change the property of your statement. We have also the transitivity. So if A is congruent to B modulus M, and B is congruent to C modulus M, then we will have A is congruent to C. Then we have another property, which is the scalar multiple property. So if A is congruent to B modulus M, we can multiply the left and the right side with a constant, a positive constant. So we will have A times K is congruent to B times K modulus M times K. Okay, there is also a scalar division property. If A is congruent to B modulus A, M, we can divide the left and the right part with a constant, for example here E, and we will have to change the modulus with which we work. So it will not be M anymore, but it will be m divided by the greatest common divisor of m and e. So we have the addition property. If A is congruent to B and C is congruent to D, both modulus M, then we can add up the left part and add up the right part. So we will have A plus C is congruent to B plus D modulus M. The subtraction is similar. So we have A is congruent to B modulus M and C is congruent to D modulus M. So we can subtract C from A and D from B, and we will have A minus C is congruent to B minus D modulus M. Then we have the multiplication property. So if we have A is congruent to B, C is congruent to D, we can multiply the left part together, which gives A times C is congruent to D times D, B times D. So we multiply the right part together. And other property will be, for example, the exponentiation. If A is congruent to B modulus M, A times A times A K time, which is A to the power of K, will be congruent to B to the power of K modulus M. And we have those two properties that we will use frequently. If A is congruent to B modulus M, we can add on the right part anytime the term M, which is the modulus. So K times M, you can add it. You can do the same thing on the left part. So if you have A modulus B is congruent to B modulus M, you can add on the left part any number of times M, and it will still be true. So let's do some exercise. You should be familiar with the modular arithmetic. Let's do some exercise just as a reminder. So we don't need this information right now. We will need it a little in the future. Oh, by the way, before we do exercises, I didn't ask you, do you have any question on the syllabus? No? Okay. So if you don't have question, let's do the first exercise. So we want to compute 22 modulus 15. The modulus is the remainder. If you divide 22 by 15, it will give you 1. This will be the quotient. And 7 will be the remainder, isn't it? So the result of that, 22 modulus 15, is 7. This is the remainder. Let me bring paint. Let me see if I can use it. Okay, when you do the division, let me with that. You use a symbol like that, no? And you put 22 here, isn't it? Divided by 15, you do it like that?
Yes.
It is like that?
Yes.
Okay. And here you put, is it like that? Or it is like that, the symbol that you use?
No, sir, it's the first.
The first one?
Yes, sir.
But do you put the 22 here?
No, sir.
Here?
Yes, sir.
Okay. So this will be the quotient. And the remainder, where do you write the remainder here? No, I don't think so. You write the remainder here, no? So the remainder will be 7, which means that 22 is 1 times 15 plus 7. So this is called the quotient, no? And this is called the remainder. So what is important when we say 22 mod 15, we want to compute the remainder. The remainder is 7. So there is another way to write the same thing. Instead of using mod, we can do 22% sign 15. It's also the remainder, it's 7. So it's another way to talk about the remainder, no? Okay. Let's go to the next one. 44 modulus 15 will be what?
Answer 14.
14, correct. The remainder is 14. 6 modulus 18 will be what? If you divide 6 by 18, the quotient will be what? The quotient will be 0, and the remainder will be 6. So 6 modulus 18 is 6. Okay? Negative 29 modulus 4 will be what? So we can use the calculator to do that. Let me show you with the calculator. I'm going to change the calculator and use the scientific calculator. Here we have a key that is called mod. So for example, we could have done 22 mod 15, and it says 7, no? Or 44 mod 15, and it says 14 as we already know. Oh, let's do the 6 mod 18. 6 mod 18, it will say 6, of course, no? So now we have a negative 29 mod 4. Let me do it with the calculator. So 29 negative mod 4. Modulus 4 is 3. So the modulus is the remainder of the division. It is always between, in the case of this division, it will be between 0 and 3. So it can be 0, it can be 1, it can be 2, it can be 3. For example, in this case, where we're using modulus 18, the result have to be between 0 and 17. Here, the result have to be between 0 and 14, no? And here it have to be also between 0 and 14. So let's try this one. What about negative 17 modulus 7? We know that the result will be between 0 and 6. What will be the value? Yeah, 4. That's true. Okay? So everybody see why 4? Okay. What about negative 7 modulus 6? So the result have to be between 0 and 5. What will be the result in this case? If you divide negative 7 by 6, that will give you what? It will give you 5, no? So the remainder or the modulus will be 5. So let me do it. Put 7 negative modulus 6, and it gives us 5, no? Okay, 14 modulus 2 will be what? So the result can be either 0 or 1. It cannot be anything else, no? Because it's modulus 2. So the remainder, when you divide, can be 0 or it can be 1. In this case, it will be what? 0, because 14 is a multiple of 2. 14 is 2 times 7 plus 0. Let's take this one, 102 modulus 5. 102 modulus 5 is what? So 102 is 20 times 5 plus 2, isn't it? So the quotient is 20, and the remainder is 2. If I take this one, 48 modulus 11, this is 4 times 11 plus 4, isn't it? 4 times 11 is 44, plus 4 is 48. So the quotient will be 4, and the remainder will be also 4. What about 33? Okay, so you can use the mod operator, or you can use the percent operator when you talk about modulus. So what will be 33 modulus 11? 0. Okay, 33 is 3 times 11 plus 0. So if you divide, the quotient is 3 and the remainder is 0. What about 18 modulus 22? So what can I say about 18? 18 is 0 times 22 plus 18. So the quotient is 0 and the remainder is 18. So 18 modulus 22 will be 18. Okay? So let's try to solve some equation to have a little more practice with the modulus. So the first equation that we want to solve is this one. 75 is congruent to x modulus 8. Of course, x is an integer number. It can be negative or positive, no, but it's an integer number. So we want to solve that. Let me use let's see if I can use it. I'm going to take a bigger save. So we have 71 is congruent to x modulus 8, and we want to solve that. So what can we do to solve that? If you pass a value from the left part to the right part, you have to change the sign. Okay, so for example, this 71, I can pass it there on the right part. If I pass the 71 on the right part, what will be the result? Here I will have 0 is congruent to x minus 71 modulus 8, isn't it? If I use one of the property that we saw, and I put this on the left and this on the right. What is the name of this property? For the first property. The symmetry property, no? It is there. Symmetry property. I'm going to use the symmetry property. I'm going to rewrite that. X minus 71 is congruent to 0 modulus 8. So if something is congruent to 0 modulus 8, what does it mean? What can I say about the left term? It have to be what? A multiple of 8, isn't it? If something is congruent to 0 modulus 8, this term is a multiple of 8. So I know that x minus 71 is a multiple of 8. So let me write that. X minus 71 should be 8 times an integer, n, where n is an integer. So it belongs to the set that is called z, isn't it? And z is all the integer, the negative, the null integer, and the positive, all the integer. So I can rewrite that x is the form, is this form, no? X is 8 times n plus 71. So this is a solution. There are many, many solutions, as you can see. It's infinite. The set of solution is infinite. But let's write down some of the solution. So let me maximize that so we have a little more space. I want to write down some solution. So, for example, if I put n is equal negative 9, what will be the result here? 8 times 9 is what? Let's start in negative 10. If I put n is negative 10, negative 10 times 8 is negative 80. Negative 80 plus 71 will be what? Negative 9. So negative 9 is a solution of this equation. It's one of the solutions. There is an infinity of solutions. If I put n is equal to negative 11, what will be the result here? So negative 11 times 8 will be negative 88. And negative 88 plus 71 will be what? Negative 17, isn't it? Negative 88 plus 71. So 88 negative plus 71, negative 17. In all cases, that will be by step of 8. So I can just say, for example, the one that come after 9, after negative 9 will be negative 9 plus 8, which will be negative 1. After negative 1, we will have negative 1 plus 8, which is 7. After 7, we will have 7 plus 8, because we go by step of 8, no? 7 plus 8 will be 15. After 15, I will have 15 plus 8, which will be what? 23, no? Before negative 17. So negative 17 minus 8 will be what? Negative 25, isn't it? So we have a bunch of solutions. Let me put ... the ellipsis to say that we have a lot of solutions that are negative and a lot of solutions that are positive. So now you can try it if you want, no? To see that it works. So this is the analytical way to solve this equation. But since we are computer scientists, we are going to use a programming language and resolve that with a programming language. So I'm going to use Python because many people use Python in the world of hacking. I'm going to use a virtual machine. So as you can see, the machine that I'm using here is let's see if this one wants to start. Okay, this one wants to start. The machine that we are using here, it's a Windows 10. And Windows 10 is very good for end user. For example, for people that don't have experience in computing, but we are advanced user. So as advanced user, we are going to use a Linux, and this is Debian version of the Linux. So I'm going to use a terminal here, and I'm going to use Python as a programming language. Python 3, okay? So if I need to do operation, for example, 22 modulus 5. What is 22 modulus 5? It's 2, no? I can ask it. As you can see, say 2. 22% 5 is 2. If I want the quotient, I use divide. So of course, it will be 4. Okay? 22 is 4 times 5 plus 2. 4 times 5 is 20. 20 plus 2 is 22. Okay. So I want to solve what I want to solve. Let me open another terminal here. I'm going to put the equation that I want to solve. So the equation is, let me just copy it. Oh, I don't see the lower part of my, oh, it is there. So the equation that I want to solve is this one. Let me copy it. And paste it here. Okay, I want to solve that. So we are going to use Python and do a small program and run the program, and I want the program to show me the solution. So I'm going to use an editor. There are many editors in Linux. I like one that is called VI. VI is short for visual. It's not easy to use. So for a person that don't have experience, I will not recommend VI. There is another editor. And when you will have to edit, use the other editor that is called Nano. Okay, so I'm going to use VI, and I'm going to call the program, for example, exercise. Let's call it, it was exercise 3. Yeah, I think it was exercise 3. .py for Python. So I am in an editor, I can type. So I want to solve this equation. What do you think? What can we do to solve this equation? So I want, since there are many solutions, I cannot show all of them. I want to show all the solutions between negative 200 and 200, for example. So what should I do is parse all the integer between negative 200 and 200, check if the integer fulfill the equation, and if it fulfills the equation, show this value. Otherwise, go to the next value. This is what I have to do, isn't it? So help me with that. What should we write here? We want to go from negative 200 to positive 200. And all the integers that are in between negative 200 and positive 200, if they are solution of the equation, we want to show them. Exactly. I'm going to do a for loop. So for.
I don't know Python very well. 4x or.
For x, yeah.
Less than or equal to whatever you need to do.
So the for, when we use the for, we have to put an iterable here. For x in, for example, range. So I want to start in negative 200, and I want to go to positive 200 inclusive. You remember the range does include the lower part, the lower limit, which is negative 200, but it does not include the 201. So it will go from negative 200 to positive 200, both inclusive, no? So what should I do here? I should check if my x verify this equation. So I will say if what? X modulus 8.
Equal 71.
So if we rewrite this equation, look at the equation. The equation is 71. Okay, let me put equal because we don't have that on the keyboard. X modulus 8. So if I rewrite it, another way to rewrite it will be what? X minus 71 is equal to 0 modulus 8, which means that if x minus 71 is a multiple of 8, so here I'm going to tell that if x minus 71 modulus 8 is equal to 0. So if it is the case, I want to show the solution. So I'm going to show the solution. Print, let's show the solution on a space. So we are going to put print x, and then we want a space, and we don't want anything else. So the end will be null, and the separator will be null. Okay, this is what I want to do. This is a program. This is my program. Do you understand that? So let me save it. So if I return to my, here I'm in Python. If I return and show my home directory, here is the program. I call it exer03.py. I'm going to execute it. So to execute it, I type Python 3 and the name of the program. So it's exer03. Here it is. Okay, those are the solutions that it finds between negative 200 and 200. So let's put the one that we had and let's compare. So here we have this one. Where is my paint? Okay, minimize that, maximize that. Okay, come back to this guy, make it smaller maybe. Okay, so look at, Here we have negative 25, negative 25. Here we have negative 17, negative 17, negative 9, negative 1, 7, 15, 23. Okay, and if you look, it's by step of 8, of course. Okay, so we did a small program to verify that. There is a lot of solution. I just show a range of solution. There is an infinite number of solutions. Okay, let's do another exercise. So this time I want to resolve this equation. So it's very similar to the previous one, no? So now you should be able to do it. So let me clean our workspace. And the equation that I want to resolve is 78 plus x is congruent to 3 modulus 5. Okay, so this 3, I can pass it on the left side. If I pass it on the left side, we'll have x plus 78 minus 3 will be what? 25 is congruent to 0 modulus 5, isn't it? What does it mean? That the left side have to be a multiple of 5. If it's a multiple of 5, I can write it x plus 75 have to be like 5 times n, where n is any integer. So let me rewrite that. It will be 5n minus 75. So of course we have an infinite number of solutions. Let's take some of the solution. So give me one solution. For example, we will have what? We'll have negative 20 is one of the solutions, isn't it? How do I get negative 20 here? What will the value of n that I choose to get negative 20? So I need to do 95. Oh, sorry, I need to do 55. 55 minus 75. How do I get 55 here? I put n in 11. So if n is 11, 5 times 11 will give you 55. 55 minus 75, negative 20. Now, if I put n in 10, it will be what? 50 minus 75. It will give me what? Negative 25, correct. Okay, I want the value that come here. So I have to take n is equal what? 12, no? 12 times 5 will be what? 60. 60 minus 75 will be minus 15. Okay, in all cases, we go by step of 5, as you can see. So 10, negative 10 will be there, sorry. Negative 10, negative 5, 0, 5, 10, 15, blah, blah, blah. Okay, blah, 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 toward the negative infinity, blah, 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 toward the positive infinity. So at the end, n have to be a multiple of 5. That's it. All the multiple of 5 are solution of this. So let's take it and program it also. It's very short. So let me go back to my virtual machine. And I want to solve this equation. So let me edit my program. What should I change here? I just have to say what? So it will be modulus 5. I want between negative 200 and 200 also. So what should I put modulus 5? It will be 78 minus 3, which is 75, plus x. So if 75 plus x modulus 5 is equal to 0, I have to show the value. Let me save this. Let me clean the screen here, and let's run it. Okay, those are the solutions. As you can see, those are multiple of 5. 0, 5, 10, 15, 20, 25, negative 5, negative 10. So as you can see, Python confirms what we find. They have to just to be multiple of 5. And look, we go from negative 200 to positive 200. You see it? This is the range that I was interested in. So I have all the multiple of 5 between negative 200 and positive 200, because this is what I asked Python to do. Okay, let's go to another exercise. Okay, this one will be also easy. So this is exactly the same thing. Let me take this one. I want to do this one this time. It's a little more fancy, no? Because we have a division. We have x divided by 7. In the previous exercise, we didn't have that. So let me write what we want to solve here. So we want to solve 96 is congruent to x over 7 modulus 5. So what do you think we can start doing? Multiply the left part and the right part with 7. So we will use which property? The scalar multiple property. If you multiply the left part and the right part with 7, the result will be true if you multiply also the value of the modulus by 7. So I can say that according to this rule, I can say that before we do that, also, instead of keeping this 96, which is big, what can I do? I can replace 96 by something that is smaller, and I will not change the equation. So what do you know? 96 is congruent to what? Modulo 5. What we did previously, no? When we do 96% 5, what is the result of that? Or 96 mod 5. What was the result of that? 1, no? Isn't it? If you divide 96 by 5, the remainder will be 1. So 96 is congruent to 1 modulus 5. Now, if I use the transitivity with these two equations, what can I write? It's exactly the same thing as what? As 1 instead of 96, I can put 1 is congruent to x over 7 modulus 5. If I switch them, I can say that it's exactly the same as this, no? I put the left part on the right side, on the right part on the left side. Now I'm going to multiply by 7. If I multiply by 7, x over 7 times 7 will be x. 1 times 7 will be 7. And 5 times 7 will be 35. Okay, I have to multiply the modulus also. So resolving this is exactly the same as resolving this. So what can we say after? We pass the 7 from the right part to the left part. So it will be 0 modulus 35. What can we say now? How can I continue? We are at this level. How can I continue? So x minus 7 must be a multiple of 35. If you divide x minus 7 by 35, you get a remainder of 0, which means that x minus 7 is a multiple of 35. So I can write x minus 7 is equal to 35 times n, where n is any integer. Okay, it can be a positive integer or a negative integer. It can be 0. So we have x will be of the form 35n plus 7. So at the end, let's see some solution. If I will go by step of 35. So 7 is a solution. 7 is a solution when I put n in 0. Give me another solution. If I put n in 1, or if I add 35 to 7, 7 plus 35 will be what? 42, no? Will be 42. Give me another solution. 42 plus 35 will be what? 77, isn't it? 77 plus 35 will be what? So we have a 2 here, and we have 11, isn't it? Okay, 7 minus 35 will be what? Minus 28, isn't it? Yeah or no? Seven minus 35 is negative 28. Let me do minus 35 to have a negative 63 will be also a solution. So I can just put it here. Negative 63. If I do negative 63 minus 35, it also will be a solution. Minus 35. Okay, I put some solution. Negative 98 will be a solution. Okay, let's verify that it is true. Let's verify that 42 is a solution of the initial equation. So let's see the initial equation. We have this, and we want to verify that 42 is a solution. So let's plug. What will be x over 7? It will be 42 over 7. 42 over 7 gives us 6. So when let's see if 92 is congruent to 6 modulus 5. Okay, 96 is 1 modulus 5, and 6 is also 1 modulus 5. Do you see it? So that's true. I can plug in x, I can plug 42, and it does work. So now let's do that with Python. I'm going to copy my equation, this one. I'm going to put it here, and I want to modify my program. So I still want the solution between negative 200 and 201. What should I write here? What do you think we should write here? So we need to write something like x divided by 7 minus 96 have to be a multiple of 5, no? But there is something here. X must be a multiple of 7 also, because here we are talking about integer. So in this case, I'm going to put first, verify that x modulus 7 is 0. And the second condition. So let's put parentheses, we see it a little better. X is a multiple of 7 on the equation that I want to verify, which is X divided by 7 minus 96 should be a multiple of 5. So here it is. Let's run that. So those are the solutions between negative 200 and 200. Let's verify this with what we have. So what we have is here. I put it here. So we find negative 98. Let me run it here. Did I run it? Yeah. So negative 98, negative 63, negative 28, 7, 42, 77, 112. Okay, as you can see, Python find the same thing. Okay. Let's do one more equation. For example, this one. So I want to do, let me clear our working space. And I want to resolve 5 times x is congruent to 4 modulo 6. Okay, what can I do with that? I want to use one property because I have 5 times x. I want x here, just x. So I will have to divide by 5. I will have to divide the left part and the right part by 5. So there is a property here, which is this one, where e will be 5. So you divide by 5, the left part and the right part. And you will have to divide the modulus by the greatest common divisor of the modulus and 5. Okay? So we are going to use this property. So I go back here. Can I divide 4 by 5? No. Okay, it's not 4, it's not a multiple of 5. What can I do? I can change this 4 and make it a multiple. Sorry, it has to be a multiple of 5. I can change this 4 and make it a multiple of 5. You remember that on the left or on the right side, I can add 6, or I can add 12, or I can add 18. So if to the 5, if I add 6, what will be the result? 4 plus 6 will be 10. And this is a multiple of 5. So there is no problem you can add here, and it will stay exactly the same one because we are modulo 6. It will be the same thing, say that, for example, do you agree with what I just wrote? If you divide 6 by 6, you will have a quotient of 1 and a remainder of 0. So now, if you add up this, it will give you 5x plus 0 is 5x. 4 plus 6 is 10, modulus 6. Now I can divide the left and the right term by 5. If I divide by 5, 5x over 5 will be x. If I divide 10 by 5, it will be 2. So what should I do with the modulus? It will be 6 divided by the GCD of 6 and 5. What is the greatest common divisor of 6 and 5? If you try to divide 6 and try to divide 5, what will be the biggest value that you can use that will divide both of them? It's 1. You cannot use something bigger. Look at 6. What is 6? 2 times 3. What is 5? It's a prime number. It's just 5. So what can I do if I want to divide both of them? I can just divide both of them by 1. So the greatest common divisor of 6 and 5 is 1. So this equation will be what? X x modulus 2, x is congruent to 2 modulus 6 over 1, and 6 over 1 is 6. So what can I say? X minus 2 must be a multiple of 6. This is what I can conclude. So x minus 2 must be of the form 6 times n, where n is any integer that you can imagine. So x is equal to 6n plus 2, where n is any integer. So let's find some value. For example, if I put n as -3, what will be the solution? So -3 times 6 is -18. -18 plus 2, -16. So -16 is one of the solutions. And since I go by step of 6, -16 plus 6 will be -10. -10 plus 6 will be -4. -4 plus 6 will be 2. 2 plus 6 will be 8. 8 plus 6 will be 14. Blah, blah, blah. Before -16, if I do -16 minus 6, it will give me what? -22. -22 minus 6, -28. So all those are solutions. So let's do our Python program to verify that we have not made any error with that. So the equation that I want to resolve is the following. Let me paste it here. 5 times x is congruent to 4 modulo 6. So let me go back to my Python program. So what should I put here? What is the condition? When x will be a solution? If 5 times x minus 4 modulus 6 is 0. This is what I have to check, isn't it? 5 times x minus 4 modulus 6 must be 0. Those are the solutions. Let me save the program. Let me run the program. So we have the solution between -200 and 200. So those are the solutions. So they must match with what we write. So I can see here -28, -28. -22, -22, -16, -16, -10, -4, 2, 8, 14. Okay, we did right. Okay, Python just go through all the integers, do it very fast and check. If it's verified, the equation, it will show it to us. Okay, so in that Python is much faster than us, and we just verify with Python that we didn't make any mistake. Okay. Find the last digit of 7 to the power of 100. Of course, we are not going to compute 7 to the power of 100. If I have the result, I can know what is the last digit. By the way, we have Python here. Let's ask Python to compute 7 to the power of 100. So tell me, what should I do here? I want to compute 7 to the power of 100. Let me enter in Python 3. So Python 3 is a calculator with infinite precision. So if I want 7 to the power of 100, even if it have a lot of digits, it will compute it for me with all the digits. So how do I tell Python compute 7 to the power of 100? What should I write here?
Isn't it just 7 and the whole up arrow thing and then 1?
No, the arrow, the caret is to make an XOR, exclusive OR. The power is ** in Python. 7 to the power of 100 is this number. So look at, it doesn't fit here. Let me put it a little larger. So the last digit is 1. This is what they want you to find. But of course, you are not going to compute 7 to the power of 100. You have to find this one, which is the last digit. If I use the caret, this is the exclusive OR between the integer 7 and the integer 100. This is not the power. For example, 2 to the power of 10, you know what it is. It's 1024. It's 1K, no? 2 to the power of 20 is 1 mega. This is 1 mega, no? Okay, so what should I do? I want the last digit of 7 to the power of 100. What idea do you have? What can we do? I can investigate all the power of 7. So I can start computing 7 to the power of 0. 7 to the power, what is 7 to the power of 0? What is the result? It's 1, correct. So it will be 1 modulus 10. Okay, let's try 7 to the power of 1. What will be the result modulus 10? So 7 to the power of 1 is 7. If you divide 7 by 10, what will be the remainder? The remainder will be 7, isn't it? Okay, 7 squared is 49. If you divide 49 by 10, what will be the remainder? Nine, of course. So 9 modulus 10. Let's do 7 to the power of 3. So I'm not going to compute 7 to the power of 3. How can I compute the remainder? Look at, I can do 7 to the power of 3 is 7 squared times 7. So I can just do 7 times 9. What is 7 times 9? 7 times 9 is 63. 63 modulus 10 will be what? 3. Isn't it? So you see, I didn't compute 7 cubic. It's too big. Of course, I can go and verify with my calculator here. 7 to the power of 3. Look at the last digit is 3. This is what I wrote. Okay, let's do 7 to the power of 4. 7 to the power of 4. What can I do? 9 by 9, 81. So it will be 1, isn't it? Do you see it? Because 7 to the 4th power is 7 squared by 7 squared. So the modulus will be the same as 9 by 9. 9 by 9 is 81. So if you divide 81 by 10, it will give you 1. So look, we came back to 1. What do you think is going to happen from now on? What will be 7 to the 5? It will be 7. What will be 7 to the 6? It will be 9. What will be 7 to the 7? It will be 3. What will be 7 to the 8? It will be 1. So what can I say? Because it becomes cyclic. So what can I say about 7 to the n? So 7 to something. 7 to the n. If n is a multiple of 4, which means that if n can be written like 4p, if n is a multiple of 4, the last digit of 7, how do I get the last digit? I do the modulus 10, isn't it? The modulus 10 gives me the last digit. So I do the modulus 10. It will be 1. If n is 4p plus 1, What can I say about 7 to the n? This will be what? If it's 4p plus 1, which means it's not a multiple of 4, but it's something like 5, or 9, or 13, or 17. For all this value, what can I say? I will have what? I am in this case, isn't it? I will have 7 mod 10. If n is of the form 4p plus 2, give me example of that. 2, 6, 10. All this power, 7 to the n will be what? Will be 9. The last digit will be 9. And finally, if it's of this type, which means that 3, 7 to the 3, or 7 to the 3 plus 4 is 7, or 7 to the 7 plus 4 is 11, what can we say? That 7 to the n in this case will be what? Will be 3. So what can I say about 7 to the 100? Modulus 10. This will be what? I am in this case, this case, this case, or this case? How can you write 100? 4p, 4p plus 1, 4p plus 2, or 4p plus 3? Well, 4p. 100 is 4 times 25. So it will be 1, which means that we confirm what Python has shown us. Now, if I ask you, what about 7 to the 201? What will be the last digit? Correct. It will be this case. 201 is 4p plus 1. Is 50 times 4 plus 1. So it will be 7. So let's do the 7 to the 201 in Python. 7 to the 201. And it ends with a 7, as you can see. It's a big number that ends with a 7. If I do, for example, 7, let's do a bigger number. 7 to the 403. What will be the last digit of 7 to the 403? So 403 can be written like what? Like 4p, like 4p plus 1, like 4p plus 2, or like 4p plus 3? 4p plus 3. So the last digit will be a 3. So let's do it. 7 to the 403. So look at 7, star, star, 403. And the last digit is a 3. You see? So I don't need to compute it, but I can still say, okay, the last digit will be that. Look, if I give you a number like 258, the last digit is 8. How do you get the last digit? Let's say that this number is called x. You do x modulus 10, isn't it? X modulus 10 will give you this 8. This is the last digit. How can you get this digit, the 5, which is the digit next to the last? How can you get the 5? Give me a formula that will give me the 5.
Modulus 100.
So x modulus 100 will give me what? 58. Isn't it? Remember that x modulus 100 will be something between 0 and 99. So let's do it in Python to verify that. Okay, so let's put x is equal, let me try to make it a little bigger. Is it bigger? No, I don't think it is bigger, no? Control plus. Doesn't mean control plus. Yeah, it's control plus. Okay, now it's bigger. Okay, I'm going to put x is equal to 258. So I want the last digit. We know that the formula of the last digit is x modulus 10. 8. Look, if now I change my x and I put this value, what is the last digit? 3. The same formula, give me 3. Now if I change my x again, same formula, 2. So it does give me the last digit. Now I want the digit that is next to the last. So here I want 6. Here I want 8. So there were one proposal that was, let's do that. So look at, it give me the last 2 digits. I don't want the last 2 digits. I want the last digit. So look at, if I change x and I put x like that, and I apply the formula, the last 2 digits is 3, 4. Give me 3, 4. So x modulus 100, give me the last 2 digits. I want the digit that is next to the last. I want this 3. What should I do? What will be the formula? So one idea, remove the 4. Remove the last digit. When you remove the 4, how do you get this 3? It will be the number modulus 10, isn't it? So first you need to remove the 4. How do I remove the 4? You divide by 10. If you divide by 10, you remove the last digit, isn't it? Look at x divided by 10. Look at the 4 is not there. We have 8, 2, 3, 7, 7, 2, 3. If I change the value of x, it will still working. For example, I put 674. I remove the last digit, which is 4, so x is 67. If I put another value of x, like that, if I remove the 9, look, I have 9203, 923. So remove the last digit and take the new last digit. I remove the last digit. When the 9 is not there, the new last digit is 3, isn't it? So what will be the formula? X divided by 10, remove the last digit. Modulus 10, give me the last digit. Not the last digit, the digit that is next to the last. So look at, what is the value of x? So this digit is 3, correct. Let me change the value of x. Let me put that. I want this 7. Okay, look at my formula. Did give me this 7. Let me change the value of x, whatever you want. I want this 6. Okay, look at my formula, it gives me the 6. So now what about if I say I want this digit? How do I get this digit? What will be the formula to have this digit? Which is 2 digits to the last. If I call this one digit 0, digit 1, this will be digit 2. I want digit 2. What will be the formula? I need to remove 2 digits, and once I remove 2 digits, I take the last digit. So you can say this will be remove 1 digit. Then I can take the result and say remove another digit. I did remove the last 2 digits. Let's verify it. Look at this number without 62. And then I say, give me the last digit of this new value. So I get the 1, which is the one that I want here. If I change the value of x, I need this 3, isn't it? So let's see. So another way to do that will be I divide by 100. If you divide by 100, I divide by 100, sorry. I divide by 100. If you divide by 100, you remove the last 2 digits. So look, the same 3. If I change the value of x, I want this 9. Okay, so let's continue. We did that. What about this exercise? Nice exercise. So they say, which digit we must substitute for A and B in this number. So this number is 1, 2, 3, 1, 2, 3, 3 million. So it depends on the value of A, but this is a digit and B is a digit, no? So that the resulting integer is divisible by 13. So I want this number to be divisible by 13. And I want to find A and B for that. So let's try to do that. Let's clean our workspace and put the number that we want to be a multiple of 13. So the number is 3, 0. Then we have a digit A, 0. Then we have a digit B, 0, 3. Do you understand this? For example, I can give you a solution. If A is 0 and B is 8, what will be the number? The number will be 3, 0. A is 0, B is 8. How can I verify that this is a multiple of 13? I just ask Python. Python tell me if it's a multiple of 13 or not. So what should I type in Python to verify that this is a multiple of 13? What should I type in Python? Help me with that. I ask the modulus 13, so I put the number 3,000,803 modulus 13. And if it says 0, it's a multiple of 13. So it is a multiple of 13. But there are several solutions. This is not the only solution for A and B. So now help me with that. Of course, the value of A have to be between what and what? Between 0 and 9, no, because it's a digit. It cannot be 10. It's 1 digit. The digit is something between 0 and 9. The value of B have to be between 0 and 9 also because it's 1 digit. So if you have to solve that, what will be your way to proceed? So we can explore the power of 10 modulus 13. So let's explore them, because this number is, since we are working in base 13, this is multiplied by 10 to the power of 0. This one is multiplied by 10 to the power of 1. This one is multiplied by 10 squared. This one by 10 cubic. 10 cube, no? A by 10 4, 10 to the power 4. This 0 by 10 to the power 5, and this 3 by 10 to the power of 6. So I might just investigate all the power of 10 modulus 13. So let's start. 10 to the 0 modulus 13 is what? What is 10 to the 0? 1. And if you divide 1 by 13, what will be the remainder? 1. Yeah. 10 to the power of 1 will be what? Will be 10. If you divide 10 by 13, what will be the remainder? 10, of course. Yeah. 10 square, which is 100. If you divide 100 by 13, what will be the remainder? Let's ask Python that, no? 100 divided by 13, the remainder is 9. Okay. So it will be 9 modulus 13. 10 cubic. So I can use 10 times 9. Give me 90. So it will be the same result as 90 modulus 13. So I can just ask Python 19 modulus 13. Of course, I can also ask 10 to the power of 3. So it say both, it say 12. So the result is 12. 12 modulus 13. 10 to the 4 is what? 9 by 9, 81. 81 modulus 13 I can do. So 81 modulus 13, which is much faster than, this is 10 to the power 4. Both say 3, of course. So it will be 3. 3 modulus 13. 10 to the power 5 will be what? So I can do 10 to the power 10 squared times 10 cubic. So 9 by 12. Okay, I'm just going to do 10 to the power 5. So 10 to the power 5, 1, 2, 3, 4, 5. Modulus 13 is 4. So here we have a 4. And we have a final value because we go up to 10 to the 6. What will be this final value? So to do 10 to the 6, I can use 10 to the 3. 12 by 12 is 144. So it will be 144 modulus 13. 144 modulus 13. Let's give me 1. Okay, good. We came back to the 1. So what can I say about the number, which is 3, 0, A, 0, B, 0, 3, modulus 13, modulus 13. Yeah, it will be equal to what? If I take this number and I do modulus 13, it will be what? So look at this 3 is associated with 1. So it will be 3 times 1 plus this 0 is associated with this 4. Then this A is associated with this 3. Then this 0 is associated with this 12, isn't it? Let me continue here. Plus this B is associated to 10 squared, which is 9. The 0 that is there is associated to 10 to the 1, which is 10. So times 10. And the 3, the last 3 here, is associated to 1, no? Which is 10 to the 0. This is 1. So I can say that this number will be exactly the same as this number modulus 13. So let me put here mod 13. Mod 13. So which is what? 3 times 1 is 3. 0 times 4 is 0. Here we'll have 8 times 3 is 3a. 0 times 12 is 0. 9 times b is 9b. 0 times 10 is 0. Plus 3 times 1 is 3. Modulo 13. Okay, so what else? We can do 3a plus 9b plus 6 modulus 13. Okay, I would like to divide everything by 3. We have this number. If we want, if we want this number to be a multiple of 13, this number have to be a multiple of 13 also. So I can write that 3a plus 9b plus 6 must be a multiple of 13. So it must be congruent to modulus 13. Okay, I would like to divide the left and the right part by 3. I can do it, no? So let's divide. If you divide 3a by 3, it will be a. 9b, if you divide it by 3, it will be what? 3b. 6 divided by 3, it will be 2. 0 divided by 3 will be what? 0. And the modulus should be what? 13 over the GCD of 13 and 3. What is the GCD of 13 and 3? The greatest common divisor. It's 1. So this is, let me pass the 2. No, let's keep the 2 here. Plus 2, 0 modulus 13. This is what I have to solve. So for example, I give you a solution. Let's verify that this solution works here. If I put a in 0, that will be 0 plus 3b. 3b will be 3 times 8, which is 24. 24 plus 2 is 26. 26 is a multiple of 13. So it's why this works. So find another solution. Give me another solution. So how should we proceed to find all the solution? We say, okay, let's assume that the digit a is 0. And you will see that if you put the digit a in 0, it forces you b to be 8. Then we say, let's assume that the digit a is 1. So if I put 1 here, what will be the equation? 1 plus 3b plus 2 must be a multiple of 13. So what do you think? This will give me 3b plus 3 must be a multiple of 13. What are the possible values of b? From 0 to 9. If you try 0 here, it will give you 3. 3 is not a multiple of 13. If you try 1, it gives you 6 here. 6 is not a multiple of 13. If you try 2, it will give you what? 6 plus 3, 9. 9 is not a multiple of 13. If you try 3, this will be 9 plus 3, 12. 12 is not a multiple of 13. If you try 4, 4 times 3 will be 12. 12 plus 3 will be 15. It's not a multiple of 13. You can go up to 9. There is no solution with a equal 1. There is a solution with a equal 2. You can find it. Okay, let me put it here. So if I put here a2, it will give me 3b plus 4 must be a multiple of 13. So what will be b? For this to be a multiple of 13? B have to be what? B have to be 3. Isn't it? 3 times 3 is 9. 9 plus 4 is 13. It's a multiple of 13. So this is a solution. A is 2, B is 3. Okay, let's do that in Python and we live with that. So let's verify that in Python. So I want this number to be a multiple of 13. Help me with a program that will do that. So look at, I want this number to be a multiple of 13. Help me with that. What should I write here? Okay, we have two variables. A, that's vary from 0 to 9, both inclusive, isn't it? So I go from 0 inclusive to 10 excluded. We also have B. And B vary from 0 inclusive to 10 excluded. So if, how can I say, if this number modulus 13 is equal to 0, show me the number. Or say there is a solution with this value of A and this value of B. So print solution with A and B. Solution with A and B, the value of A and the value of B. So format, I'm going to show A and B in the placeholder. This is a placeholder for B, this is a placeholder for A. So of course, if I write that, what will happen? If I try to run that, Python is not going to understand this number. This is not a number. So how do I write this so Python understand it? How can you write this number a different way? How can you write that? This number is 3, 0, 0, 0, 0, 0, 3 plus what? Plus what? Plus A time 1, 0, 0, 0, isn't it? Plus B time 1, 0, 0, isn't it? So instead of writing that Python will not understand it, we're going to understand this. So I'm going to say, if this number, let me put it in between parentheses. If this number is a multiple of 13, show the value of A and B. So let's run this program. Let me do it here. Control D, Python 3, exer. Oh, colon is missing here after the if. Okay, I did tell you that there were solutions 0, 8. We did find together the solution 2, 3. The solution 2, 3. Look at the other solution. 3, 7, 5, 2, 6, 6, 8, 1, 9, 5. Of course, we started, when we did it, we did say, okay, if A is equal to 0, it forced me B equal to 8. If A equal to 1, there is no solution. If A is equal to 2, it forced me B to be 3. So we keep going. If A is equal to 3, it will give you B equal to 7. If A is equal to 4, there is no solution. And you keep going up to if A is equal to 9, and it will give this solution. Okay. We will need the modular arithmetic very soon. It's why I did a review with you. Please work a little on it. So when we see the public key cryptography, it will be much clearer for you because you will have a refreshment of modular arithmetic. Okay, thank you so much for attending the class today. I see you next week.